Hi, in this session we will look at solutions of certain trigonometric equations. Now we already know that solution to the equation cos x equal to 0 is x equal to 2n plus 1 times pi by 2, where n belongs to the set of integers, that is all values of angles which are odd integer multiples of pi by 2 satisfy the equation cos x equal to 0. And similarly we also know that the solution to the equation sin x equal to 0 is x equal to n pi, where n belongs to z, that is all angles which are integer multiples of pi satisfy the equation sin x equal to 0. Now what if we are given an equation cos x equals a constant a, that is, we know the value of cos x, so that we know one possible value of x which could be a primary solution of cos x equal to a by looking at the value of a and the unit circle method that we have explained earlier. So let us say that we know one primary solution of cos x equal to a, and that solution is x is equal to y. So we can say that cos x is equal to cos y is one solution that we know. So here x is a variable which is unknown and y is a constant. We know y. Now can we find a general solution for x? Now we can write this equation cos x equal to cos y as cos x minus cos y equal to 0. And we know from earlier derivation that cos x minus cos y is equal to minus 2 times sin x plus y by 2 times sin of x minus y by 2. So therefore we have been able to convert this equation cos x minus cos y is equal to 0 in terms of a product of two functions, which is sin x plus y by 2 multiplied by sin x minus y by 2 is equal to 0. Now this is useful because it implies that either sin x plus y by 2 equal to 0 or sin x minus y by 2 equals 0, and therefore we can apply the solution for sin x equal to 0 here and say that cos x is equal to cos y implies that either sin x plus y by 2 is equal to 0, which means that either x plus y by 2 is equal to n pi, where n is an integer, or x sin x minus y by 2 is equal to 0, that is x minus y by 2 is equal to n pi. That is, either x equals 2n pi minus y, or it is equal to 2n pi plus y, and we can combine both these possible solutions into one by saying that x equals 2n pi plus or minus y, such that n belongs to the set of integers. Now suppose that we know the value of sin x. Let us say sin x is equal to b, in such a way that we can express that as sine of a particular angle y. It could be a principal solution of sin x is equal to b. That is, x here is the variable unknown and y is the known constant. Now can we generalize the solution for x in the way we did for cos x is equal to cos y? Here we have sin x is equal to sin y. We don't know x and we know y as one particular solution, and we can write this as sin x minus sin y equals 0, and we know that sin x minus sin y is equal to 2 cos x plus y by 2 sin x minus y by 2. And this again is a useful formulation because it implies that either cos x plus y by 2 has to be 0 or sin x minus y by 2 has to be 0. Sorry, that's not y but 2. Now if cos x plus y by 2 is 0, then we know that x plus y by 2 should be an odd integer multiple of pi by 2, that is 2n plus 1 times pi by 2. Or if sin x minus y by 2 has to be 0, then x minus y by 2 must be an integer multiple of pi, that is n pi. Now this implies that x is equal to 2n plus 1 times pi minus y, or it is equal to 2n pi plus y. Now if you look at these two possible solutions, what you see is that the coefficient of pi in one case is an odd integer and in the other case it is an even integer. So we can combine that by saying that x equals n pi, where n is any integer. It could be odd or even integer. But we see that when n is an odd integer, the coefficient of y is minus. Whereas when n is an even integer, the coefficient of y is positive. So therefore we can say that the coefficient of y depends on whether n is even or odd, and we can write it as minus 1 raised to the power n whole times y, so that when n is even, minus 1 raised to the power even integer becomes plus 1. So the coefficient of y becomes positive, whereas when n is an odd integer, the coefficient of y becomes minus 1. Now in a similar vein, let us try to find the solution for tan x is equal to c equation, where c is a known number, such that we can express it as tan of a particular angle y, let us say, which could be a primary solution. So here x is an unknown variable and y is a known constant, and the question is, can we find a general solution for x? Now we can express this as tan x minus tan y equals 0, and if we express tan x as sin x by cos x and tan y as sin y by cos y, and we take the LCM of cos x cos y, then we can write this as a ratio where cos x into cos y is in the denominator, and in the numerator we have sin x multiplied by cos y minus sin y multiplied by cos x. Now for this ratio to be equal to 0, its numerator must be equal to 0 and the denominator should not be equal to 0 for the ratio to be defined. Now if we look at the numerator, sin x cos y minus sin y cos x, it is nothing but sin of x minus y. And if that has to be equal to 0, then it implies that x minus y should be equal to n pi, or x should be equal to n pi plus y, where n is an integer number, and at the same time cos x or cos y cannot be 0, which means that neither x nor y should be equal to 2n plus 1 times pi by 2. And for the sake of completeness, we mention that n belongs to the set of integers. Now, these solutions to these 5 trigonometric equations are quite important and useful to find solutions of general trigonometric equations that you may be asked to solve. So let me just mark them here by these boxes. This is the solution for this equation. This one is the solution for this equation. This one out here, x equals 2n pi plus minus y, is the solution for this equation. This one is the solution for this equation, and finally this one is the solution for this equation. And in the similar way, you can now find out solutions for other equations like cosec x is equal to cosec y, where we know y and we do not know x, and sec x is equal to sec y, cot x equals cot y, etc. Okay, so now see you in the next session. Bye.